Hi, welcome back to the Walker Test Lab. I'm Joe Baccarella, and with me is Deneen Myers of the Walker Emissions Control Team. We're going to talk about catalytic converters and what causes these sophisticated components to fail.
Any number of problems can damage a converter, and these issues must be corrected before installing a new one.
So let's take a quick look at the 4 primary types of converter failures. The first is what we call poisoning.
Poisoning is the contamination of the converter's internal honeycomb substrate. Once the substrate is contaminated, it loses its ability to clean up emissions.
A few common poisons that will destroy the substrate are antifreeze, leaded gasoline, and some engine oil additives, and certain chemical sealants that are incorrectly used when servicing gaskets.
Antifreeze in the exhaust stream indicates a serious problem with the engine, probably a cracked or leaking cylinder head or failed intake manifold gasket. Intake manifold leaks in particular have become a real problem due to the use of composite intake manifolds. In each of these cases, the issue obviously needs to be resolved before the converter can be replaced. Leaded fuel should never be used on a vehicle equipped with a catalytic converter, as the lead will quickly damage the honeycomb structure. Some performance enthusiasts use oil additives containing zinc, which is claimed to reduce engine wear. Problem is, oil companies significantly reduce the amount of zinc in their oil formulations specifically to prevent converter damage. So save yourself some trouble down the road by avoiding zinc-based additives.
Poisoning can also be caused by the use of non-converter friendly silicone sealants in the engine or exhaust system. If you're going to use a silicone sealant, be sure to select one that won't harm the catalyst.
The second type of converter failure is a coated or oil-fouled substrate. Here's a great example of what this damage looks like.
The substrate is a ceramic brick with small square channels. Its surfaces are covered with a wash coat and a mixture of precious metals that create the chemical reactions needed to clean up engine emissions. If the precious metals can't make contact with the exhaust flow, the gases leaving the converter won't meet emissions requirements.
The most common causes of coated substrate are excessive carbon buildup and excessive oil consumption.
A serious oil consumption problem is usually a sign of severe engine wear. You must repair the engine before installing a new converter, otherwise the replacement converter will suffer the same fate.
The third type of converter failure is an overheated or melted substrate. This is usually a sign that the converter has been forced to work too hard and generate too much heat due to excessive hydrocarbons, carbon monoxide, and oxygen in the exhaust stream.
The most common contributor to this issue is a fuel control or fuel quality problem. Other potential causes are worn O2 sensors, a restricted air cleaner, low engine compression, poor spark or weak ignition, and excessive engine load.
Structural damage is the fourth primary cause of converter failure. By far, the most common scenario is physical damage from road debris, which should be easy to see on the converter shield and shell. Other types of physical damage are corrosion from road salt, metal fatigue, stress fractures, stripped O2 sensor threads, and failure of the flex pipe or air gap pipe.
Another very common form of physical damage comes when the converter is operating at a high temperature and is suddenly cold quenched in water from a deep puddle or perhaps snow or ice. This thermal shock can destroy the ceramic substrate.
Well, Joe, that's our review of the 4 primary types of converter failure. Bottom line, these components don't fail on their own. An outside issue, often related to the ignition, fuel system, engine, or engine controls, has caused the failure. And you've got to fix the root cause if you want your replacement converter to last.
Thanks for joining us. Deneen will host the next program in this series, an overview of the 13 steps of proper converter diagnostics.
See you again soon.